Hi guys, today I want to recycle my circuit board from my lithium-ion battery pack, which used to power my electric bike. And okay, this one is a very old pack I used to have, and it lasted for 3.5 years. After that it went down, and I opened it and wanted to see if I can change or maintain individual cells. However, the cells seem to be glued inside these plastic packs, and since I didn't know what was inside, the only option I had was recycling 3 of my packs, taking them apart, putting 3 of these in parallels, and then I had another pack I could use for about a year, and so then it finally went down all the way. So after that I got me these LiPo cell battery packs, and they went down after like 1 year, and 2 years they're all dead. And when I opened them, I some kind of got a shock what it looked inside. So there was no way to repair anything or to change anything. They were just glued together. And so I decided to take my old circuit board here and build my own pack using these 18650 battery cells. That's, I think, a new standard in the industry, and they are 18650A Li-ion battery packs. This one is from Panasonic, made in Japan. It holds 3100 milliamps, and I think they use these ones inside this pack here. I mean, I couldn't look inside, but I think because the size matched exactly the width of the board and the width of these plastic packs, so my thinking is these kinds of cells were inside, maybe 5, maybe 6, and then in parallels, and maybe 2000 milliamps at that time. So a little bit to the technology here. It's quite simple. Basically you have here 1, 2, 3, 4, 5, 6 and 7 of these packs in line. Then each of these packs most likely contains like 5 or 6 of these cells, so they are in here. So let's see if I can just I just do it like this. 1 and 1, 2, let's say it's 3, maybe 3, 4, 5 in each of these, like that. So it's 3 here, 3 here, 3 here, or 4, 4, 4, 5, 5, 5, whatever. Okay, and each of the cells has 4.2 volts. That's the maximum charge, and the minimum, I think, is for this case here 3.42 volts. Then is cut off, which means the batteries will stop functioning at 3.4 volts, and the engine will turn off. For these Panasonics, I think you can discharge them further down to 2.5 volts, but I never will do that. So how is it set up? Here is the minus connection, and the minus connection goes here into the circuit board, or circuit balancing board, which will make sure that by charging and discharging, all these packs have the same voltage, 4.2 volts or 3.4 volts, not lower and not higher. So this one will go in here, this goes in here, that minus goes in here, and so it goes, just as you can see, all the way down to the last one. And the last one here, this one here is different. One second. This one here is minus, and this one is the last one that is plus, that goes into the circuit board. So here's the minus, and here is the plus, which goes into the circuit board here. So this one goes here, the minus, and here is the only, one second, no, that's the, sorry, I got it the wrong way. So this one here is the minus connection, and this one is the only plus connection going into the circuit board. So from here to here, this should be 29 volts. Okay, so this is the first minus connector, then you're connecting them all the way in line, and if you come down to here, then minus plus, this is 29 volts. So the green cable here, this one is for charging, and then you also have here two fuses, one is here and one is here, to cut off the whole thing if something is wrong or out of balance. And here is the minus connection for the battery pack, for the engine, and here is the plus connection for the engine, adding to 29. I think at full charge I would have 29.2 volts. That's where my charger cuts off. It could be 29.4 volts, but it's 29.2 volts, and then for each of these cells they get a maximum charge. Each of the cells gets a maximum charge of 4.17 volts. I mean, it could charge up to 1.2 volts, but it 4.2 volts, but it charges to 4.17 volts. So, and my intent is to use, my first intent was to use some cheap cells from China, nice color, blue, and they stated to have 4,600 milliamps, and I thought, wow, then I can take 12 of those in line, adding up to 84, and I would have a battery with 55 ampere hours, and the battery cells were very cheap, only like I think $3-4 each. However, it was a scam, and I only got like maybe 1,200 milliamps out of each cell. So big embarrassment, and I went back to these salespersons, and they hooked me up with these Panasonic 3,100 milliamps, brand new from Japan. They all came at 3.6 volt charge, which is the nominal charge for these batteries. Okay, so one more thing I want to show you is on the next one here. This is what the battery pack looked like before, when it was assembled completely. And this was my next battery pack I used to have, and they are these lipo cells inside. One of them blew up, the whole pack is gone. I had 6 of those. After 1 year they all went down. And so actually it's pretty much the same technology, looks a little bit different. The only difference here is, yeah, these cables here connect into these packs, and of course you can't see anything here because it's just a disgusting gluey mess here. So I think these cables go the same way. One is going to the first, second, third, fourth, fifth, and so on till the last connection. So basically these cables that you see here are the ones that go one by one into the pack as they go in line. So I thought of recycling this kind of balancing board, but since it looks very unprofessional, and I was very happy with the battery pack before, so I went with this other balancing board, with this one. Okay, let's start with the video and how to do it. Okay, here are the battery cells, and I bought them brand new. They're supposed to have 4,600 milliamps, which at 3.7 volts, it should be like 4.6 ampere hour. And here are the old controllers for the old battery sets I used to have. So this one here is a newer one. They were a little smaller at 10 ampere hour, but they only lasted for a year and then they went down. Okay, here are the templates I printed out, so I will upload these templates to YouTube. And these templates, you just glue them to the copper plates. I have no idea how big they're supposed to be, but I guess this one here is a 0.5 millimeter of copper from the size, right? So the next thing you do, you take this stuff for soldering, and you roll this one around the pen just like that. Make it nice and tight, and when you're done, maybe as many as you need, you just cut them off like that. So you will end up with these rings, and put them nicely together, and then you can put the ring onto these copper plates pretty much in the center. So I decided here, these ones I glued in place with normal white glue and one corner, so I put a little drop of white glue to the corner to fixate them, so that when I move them around they do not fall off. So, but these ones here, I used a different glue. I used this glue stick here, and I'm not so sure if it's a good idea, but I will try out. So just put the glue one time to the back, a little bit, not too much, and then just put it onto, oh, I got it on my finger, onto the copper plate right into the center. Okay, here you can see the templates, and I put the templates onto the copper plates. So I think they're like 13.5 centimeters to 4.5 centimeters on each. I made a row of 12 of 2x6 batteries. I left space in between for the air to flow, and I put the templates onto the copper plates by simply using glue. And in the center I put the silver for welding the nipples onto the copper plates right into the center. One more thing I have to do is I have to use, I made me these tiny pieces here, and these ones I will flatten with a hammer and put them here into the center. And on top of this will come these nipples, as you can see over here. You can see, so underneath is some of the silver, and then this one goes on top. So, and then wish me luck with burning those. Okay. Okay, here's the finished result, and yeah, they're not everyone is exactly in the center, but I think they're nicely holding on to the copper. And if I put the template on top again, then you see it's pretty much in the center. So if I take now one of the cells and I line them up right above the hole, then they will always touch the tiny nipple. So what you here see is the almost finished product. So here is going to be the control unit. It's going to be here on the top. I'm designed an outer case. It's made of aluminum, and and I changed my mind. Before I used this kind of wood to make my battery or my cell holder, but then I discovered I wanted to use a very light wood, but it kind of is too flimsy. So I think you can use wood if you want to, but I went for a little bit more high-tech, and I got a company to design me the battery holder with plexiglass. Okay, I will show you. So here's the batteries. They go into this holder, and I just kind of hold it like this right now. So I can take it out right now. So this one is the top unit. It's gonna be held in place by screws around here. And okay, my coffee water is boiling. 1 second. Alright, sorry about this. I got me my cup of coffee. Okay, so let's go. Basically, this one here is the aluminum case, and inside the aluminum case is, I hope I can take it out now. Yep. It's this piece of plexiglass, and the plexiglass is holding on to the copper plates. The copper plates are holding on to these cables, and they have the springs inside. And inside the aluminum case is, of course, another layer of plexiglass. So this plexiglass goes inside the aluminum case first to make sure that the electricity can flow inside the aluminum case, and inside this goes this piece of plexiglass with the battery holders here. And this one here, I kind of soldered it by kind of cutting the overlapping copper and then rolling it around the cable and soldering it with soldering iron. So it kind of gave the aluminum box a little bit extra space so that this one will fit in here. And of course I will have to drill holes around the edges, this side, and that side, and drill into the plexiglass to hold this stuff here in place. And I don't want to glue anything, I just will hold it with several screws going all the way around. So these cables will come through little holes here through the top, and then here on the top will be not this black part here, but this one will be held into place also. I will have a little kind of box made of plexiglass, and this one will hold this unit about like this, and the cable will come from underneath and will pass through holes and go into this board here. So what you see here is I loaded a few batteries inside, and so basically the idea was that this would fall on top of the batteries and the nipples would push down on the batteries itself. But since I left a little clay in here, so my concern is that maybe one nipple will kind of push on the side and somehow either damage the battery or not making a proper connection. And so to ensure that this works out 100% of the time, I made this kind of plexiglass design with 12 holes each for each compartment one. And I used this kind of aluminum paper. I spread this out, use the AB glue on a second piece of plate or whatever, then push the plexiglass onto the AB glue and then onto the copper. Then later I cut out about 3-4 millimeters of the copper with a razor knife and took this off to make sure that never ever one of the compartments can shortcut to the next one. And also I covered it one more time with AB glue on top here around the edge. So these ones go now like this, and they will make sure that I have 100% connection each time. Okay, so once everything is in place, this one should close the box, and inside of course the batteries and these pieces below, and the final thing will be the lid, which I had to change. So I got me some thicker aluminum. It's adding weight, but the other aluminum was too soft, and I thought it might create a bubble in the center and not allowing the batteries to connect properly. So here, that's what it's going to look like, pretty much. So this one here is the circuit board, and the circuit board, I had to go with the cables through the top of the aluminum. So what did I do first? First I put the circuit board on top of the aluminum, and I marked the holes where the cable have to be connected. Then I drilled the holes, and I drilled bigger holes, I think about like 10 millimeters or even bigger, and sanded everything very nicely, and then covered the hole with the aluminum with AB glue, and on top of this put a sheet of this insulation plastic. And then from the other side I did the same thing, and filling out the holes with AB glue. Then second step, putting in the center of these holes a new hole, so that basically around the cable is maybe 2 millimeters of AB glue before it touches the aluminum. So when you cut the cables came out about this long, and I always made sure that minus, plus, minus, plus, minus, plus, from the left to the right, they came in the order as they're in here. So whichever is to the left, and then to the right, and then to the left, and to the right is always the next unit, so I always know which is which. That's not very convenient for putting the cables to the board, so what you have to do is you have to lay the cable into circles onto the case, and duct tape them and cut them exactly so they end up above the hole where you want them to be. And so on each of these holes go 2 cables. Only the first one has 1 and the last one has 1. This one has a positive cable, and this one here has a negative cable. All the others have 2. They have the positive from the previous unit, from the previous cell, and the negative from the current one. So number 1 flows plus into the second one. The second one has the minus here plus the plus from the first one, and so on and so on. And when you come to the last one, you only have a plus. And of course I recycled the holding unit for the circuit board, which is in this fashion sliced onto the circuit board, and then you can push it down into position. And last thing I need to do, find a solution how to get hold onto the case. So well, that's what I want to do. I want to recycle this one here. So I took the whole case and I cut the case in order to get just the part that is responsible for holding this circuit board here. And here you see 2 cables for plus and 2 cables for minus. It's supposed to be 1 cable, however these cables tend to get hot, and so I decided to have double redundancy. So 2 cables for the plus, 2 cables for the minus, and I did this in order to make sure they can handle the voltage and do not get too hot. I got a full delivery of the new Panasonic 3100 milliamps, and now I'm checking the voltage, and each of them, I don't know, can you see that? Each of them turns out to be right on 3.6 volts exactly. So if they are new and original, I think that's the way Panasonic delivers these batteries. So I will check them through now and then put them into my battery case. Good. Okay, here is one more thing I want to show you. Before I used the blue cells, and these blue cells they had tops, while the Panasonic don't have tops, and when I started charging my battery pack, I noticed that something went wrong. It just turned off after charging to about 20.8 volts. And so I opened the pack and checked the cells and found in one unit 4 cells or 5 cells that didn't charge at all. And then in the other units about 2 or 3 cells that weren't properly connected. So what I did is I first turned on this side, take the screwdriver, mark the center, then turn this one around, put this piece of this kind of foamy stuff behind it, and then mark the center one more time, push it down and draw a circle around it with the screwdriver, and then slowly but surely press downward. Then once you're done with that, put soldering iron into the hole and heat it up a little bit. So what is the conclusion about my battery pack? So I took it for a ride, or better, my wife and I, we took it for a ride. We started here near Taipei main station. We went up Zhongshan North Road and we went into the river park, and the river park goes all the way along the river all the way to Damshui, which is about I think, let's see, 22 kilometers. So 22 kilometers to Damshui and then 22 kilometers back. 2 people on one bike doing this trip. And when we came back here, the battery was still more than half full, or about half full, and I decided to take it on my own the next day one more time. So I went one more time, this pretty much the same route, but not all the way, about to here and back, which is another 16 to 17 kilometers per journey, so together 34, I guess. So together 44 and 34 is something like 78 kilometers. And when I came back home, I realized I still had enough juice probably for another 10 kilometers. So it's somehow an 80 kilometer range battery pack I have. I already did the trip like 2-3 times. With recharging, it always charges to 29.2 volts, and it doesn't lose any charge. There is no electricity in the case, so everything looks fine. And I think building the battery pack was a success. One more thing, loading the battery takes from after making the 2 trips to do Damshui and back, the 78 kilometers, charging will take about 8 hours on my charger. But that's what I actually wanted. I wanted to have each cell charged at a very low rate, not so fast, because they are rated at 500 recycles, on 500 life cycles, which means it's then 80 kilometers and then times 500, it turns out to be 40,000 kilometers. And so I can have this battery for 3 to 4 years before it goes down to 90%. That's what I'm expecting. And if some cells break, I can easily exchange them. Them opening and closing the case takes no more than 5 minutes. Okay, thank you for watching, and check out my channel once in a while. Thank you.